Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 9, Lesson 2 on the area of a triangle. So this unit is all about geometric shapes and measuring their area, right? And as we discussed in the last lesson when we looked at the area of a rectangle, area is just the property of a two-dimensional figure, like a flat figure, that measures how much space lies inside of the figure. Now there's a lot of different ways of measuring space, right? But the most common way in terms of area is to measure how many squares of a particular size fall inside of a figure. Now that made a lot of sense with rectangles because rectangles, they are rectangular. They have right angles, so it's easy to visualize filling up that kind of shape with these squares. Today, we're going to explore triangles and how to find their areas. And yes, I know that this is a review topic, but we really want to kind of dig in and talk about how you can find the areas of triangles using a particular formula and why that formula works. So let's jump into it right now. In our first exercise, right triangles are what we're going to begin with, and they're really going to be the basis of all of our work. And right triangles, recall, are triangles that contain a right angle. They can really be thought of as just like half a rectangle in essence. And this really is the key to understanding their areas. So let's jump in and take a look in exercise 1, first at a rectangle and then a right triangle. Exercise 1, rectangle ABCD is shown below. Recall that all rectangles have 4 right angles and adjacent sides that are perpendicular to each other, which basically just means they form right angles. Letter A, what is the area of ABCD? Include appropriate units in your answer. All right, simple enough. We did area work with rectangles last time, so why don't you pause the video really quickly and figure out what the area of this rectangle is. All right, and again, remember, what I'm literally thinking about is how many squares that are an inch by an inch by an inch, right? A square that's just got side lengths that are inches, right? How many of those would fill this up? And that really is how we want to think about and understand the area formula of a rectangle. Because the area formula of a rectangle can always be just found by doing length times width, right? Which is going to be 12 inches times 5 inches. And that's going to be 60 square inches, which we can write probably most compactly like that. Right? So simple, right? No big deal. Now, let's take this rectangle and let's carve it into a right triangle. Let me just bring this up a little bit. Letter B. Draw a line segment from point A to point C. Redraw the resulting right triangle ACD below. All right, so this is easy enough. With my magic, I'm just going to draw that thing in like that. All right, so all I'm doing is drawing a line segment from A to C. I'd like you to do the same, and then I'd like you to take this right triangle, redraw it down here, and label the 2 dimensions that you know on it. Pause the video now and do that quickly. All right. So that's easy enough. Let's get that right triangle in there, get this out of the way so that you can see it. There it is. Now, if it isn't obvious, right, this right triangle, right, is the same as that right triangle. And we could see that actually by taking that right triangle, maybe even putting it on tracing paper, rotating it, and we'd find that it was the exact same as that one. Which leads us to letter C, right? What is the area of triangle ACD? Explain how you determined your answer. Well, I'd like you to pause the video now and tell me how many square inches lie inside of that triangle. Well, hopefully it's pretty easy. And the answer is going to be 30 square inches. Now, there's a really good reason for that. And that's because there is half the space, i.e. the area, in this triangle that there was in the original rectangle. And it's pretty much that simple, right? My original rectangle, ABCD, contained 60 square inches, right? When I draw this line in, I divide it up into two identical right triangles, which, unless like division totally doesn't make sense, right, then the whole point of it is half of that area has to be included in this right triangle, and half the area has to be included in that right triangle. So I can simply take my 60 square inches, divide by 2, and I find the area of my right triangle being 30 square inches. Right triangles are simply half rectangles. That's all they are. So it makes a lot of sense to take the area of the original rectangle, divide it by 2, or multiply by 1/2, whichever one you want to think about, to get my 30 square inches. Let's keep going. Right? This leads us to a very important formula, exercise number 2. Based on exercise number 1, state a formula for the area of a right triangle whose base is given by B and whose height is given by H. All right, so it's very, very simple, right? If I've got some kind of right triangle, then I can always sort of think about it as one edge sort of being horizontal, and I'm just calling that the base, and then one edge being vertical, I'm calling that the height. The third side is what's known as the hypotenuse, but we're not going to worry about that right now. So what is the formula for this? Well, if this was a full rectangle, right, if we had a full rectangle in here, then of course the area of that rectangle would be base times height, or length times width, right? It doesn't really matter what we call them, it would be base times height. So once we divide this into two identical right triangles, then the area is either going to be base times height divided by 2, or 1/2 base times height. Okay? These are, and I want to be very clear about it, equivalent formulas, right? It just depends on which one you like better. Do you like it better to think about it as taking the base, multiplying it by the height, getting an answer, and then dividing by 2? Or do you prefer to think about it as taking the base, multiplying it by the height, and then multiplying by the number 1/2? Either way, you're finding half the area of a rectangle. That's what you're doing. So let's keep doing this. A little more work with the area of triangles. Exercise number 3. What is the area of the right triangle pictured below? Include appropriate units. All right, fair enough. I'd like you to pause the video and figure out what the area of this right triangle is. All right, so the only reason I kind of toss out a very easy one like this, easy in quotes because that's in the eye of the beholder, is the fact that I've given you all 3 side lengths here, 6, 8, and 10, and you have to decide which one's the base, which one's the height, and which one's irrelevant. Well, the plain fact is the 10 is irrelevant. Even if this picture was rotated in some way, the 10 would be irrelevant. For a right triangle, the thing that's important in terms of its area are the 2 sides that are perpendicular to each other, the 2 sides that then form that right angle. Once I have that, I can either think of it as the area equals 6 times 8 divided by 2. 6 times 8 is 48. 48 divided by 2 is 24 square centimeters. Or I could think about it as area equals 1/2 times 6 times 8. Now, just for a minute, I'd like to talk to you just a bit about this approach. Again, you like this approach? Awesome. This approach would tend to work a little bit better, let's say, if the 2 lengths here were fractional. Then it might be nicer because, we all know how to multiply fractions by fractions. Whereas up here, we'd have like a fraction, maybe times a fraction, divided by 2. That could get confusing. There's also another nice advantage of this formula, which is that multiplication is what's known as associative, meaning that if you've got 3 numbers that are multiplying each other together, you can decide the order in which you want to multiply them. So if I were doing this, I might decide that I'm going to do the 1/2 times 6 first, which would be 3, and then I could do 3 times 8, which would give me that 24 again. So that's kind of nice, right? If I have 1/2 times a number, especially if one of the two numbers is even, then it kind of is easy because I could do that 1/2 times the even, which is essentially just taking the even and dividing it by 2, and then I could take that result, right, and multiply it by that final number. I can do the same thing with 1/2 times 8, get myself 4, then do 4 times 6, and also get 24. It's that simple. Now, right now we know that the area formula for a right triangle is 1/2 its base times its height. But we don't know how to find the area of non-right triangles. So that's what we're going to explore in the last two exercises. Let's take a look. All right. So what happens when the triangle is not a right triangle? In other words, what do we do if two sides are not perpendicular to each other? And that's more often the case, really. So let's take a look at exercise number 4. In triangle ABC, its base has a length of 15 inches and it has a height of 10 inches. Point D has been located on side BC such that two right triangles are created, ABD and ADC. Letter A, find the area of the two right triangles. Now I just want to pause for a second before we even get into A. The idea is, and it's a little bit hard to see because I've already drawn everything in here, the triangle I really care about is triangle ABC. All right, this triangle. And it's got a base length of 15 inches. The height then isn't one of the sides. The two sides of ABC, the two remaining sides are side AC and side AB, and I don't even know what their lengths are. The height is literally like how far is point A away from the base. That's what the height is, right? So what I've now done is I've drawn that height in, and that then divides my original triangle into two right triangles. And the beauty there is I can find their areas because I know how to find the area of a right triangle. So what I'd like you to do right now is pause the video, figure out the area of this triangle, that's triangle ABD, find the area of this triangle, that's triangle ADC, and then we'll add them together in the next part of the exercise. Pause the video now and go ahead and do that. All right, great. So first I'm going to figure out the area of triangle ABD, right? It's got a base of 9 inches and it's got a height of 10 inches. So the area here is going to be 1/2 times 9 times 10. All right. Now one thing I could do is I could take that 1/2 and that 10 and make this into 9 times 5, and that would give me 45 square inches. Likewise, you could just do 9 times 10, get 90, divide by 2, and get 45 square inches. That's fine. That's for this triangle. Now let's do the smaller right triangle over here. That is going to have an area of 1/2 times 6 times 10. In this case, maybe I'll take half of 6 and get 3. 3 times 10 is going to be 30, and that's going to be 30, oops, not square centimeters, can't change the units on you there, 30 square inches. Okay. Now, the whole point of area is that it measures the space inside of a figure. So given that the overall figure, ABC, is made up of these two right triangles, it should now be pretty easy. In letter B, they ask us, what is the area of triangle ABC based on A? Well, hopefully I would agree, on just a general principle, right? If I had a big bag, and I had two smaller bags inside of it, and one of them held 45 something and one of them held 30 something, and I wanted to know what the overall bag held, I would just add these two together. And it's the same way with area, right? If I want the area of this overall triangle, I'm just going to take these two, add them together, 45 square inches plus 30, there's my plus square inches, and that's going to be 75 square inches. That's it, right? That's easy enough. Now, the problem is, right, we don't really want to have to do it this way. I don't really want to have to break it up into two figures and add them up, especially given the fact that I may only know the 10 and the 15. I may not know how the 15 got divided up. So let's take a look in letter C. How could you have calculated the area of triangle ABC without breaking it into two right triangles? Show the calculation below, right? Well, remember, our original formula for the area of a right triangle was to simply take its base, which in this case is 15, its height, which in this case is 10, multiply them together, get an answer, and then divide by 2. Well, the remarkable thing here is that it still works. Take a look, right? If its base is 15 and its height is 10, right, then the area, which would be 15 times 10 divided by 2, is 150 divided by 2, and that is still 75 square inches. The point here is that our formula for the area of a right triangle now works for one of these triangles. The key is, and this is important to understand, in a non-right triangle, the height is not one of the side lengths, right? So AC and AB, we don't know their lengths, but we do know that the base, sort of the side length that the triangle is sitting on, right, is 15. We know its height is 10, right? So that's the distance from the other vertex down to the base. And if we simply do the base times the height, and divide by 2, we still come up with the correct area, which is awesome because that means we don't have to invent a new formula to find the area of non-right triangles, right? It's still take the base, take the height to the base, multiply them together, and divide by 2. Now there's one last type of triangle though that we want to play around with just to make sure this formula still holds, because who knows, maybe there's some kind of a triangle that it doesn't hold for. So far what we've done is we've looked at a triangle that is a right triangle. This is what's known as an acute triangle. All the angles in ABC are less than 90 degrees. So the last thing that we're going to look at is the area of what's known as an obtuse triangle, one with an angle greater than 90 degrees. So let's check that out in the last exercise. The area formula for a triangle works even if it's not a right triangle. The key is that the height is simply not one of the side lengths. Exercise number 5. An obtuse triangle is one that contains an angle greater than 90 degrees. In the diagram below, triangle ABC is obtuse and has side BC extended to point D such that two right triangles are formed, triangle ABD and triangle ACD. Determine the area of both right triangles below. So again, let me just be very clear about it. Let me throw in the right angle symbol, which I probably should have had on this diagram in the first place. We've got some larger right triangle, which is this one, and then we've got a smaller right triangle, which is this one. And again, because they're both right triangles, I can figure out what their areas are by just using 1/2 base times height. So why don't you go ahead and find out what the area of triangle ABD is. Again, remember that's ABD, and triangle ACD, which is ACD. All right, pause the video now and find those two areas. All right, well, we have to do a little bit of work on triangle ABD, right? But only because we need to think a slight bit about what the base is, and that's 14 centimeters. So the area of ABD is going to be 1/2 times 14 times 5. And again, I like doing that 1/2 times 14 and getting 7. And then I'll do 7 times 5, and I'll get 35 square centimeters. All right. Now for the smaller one, triangle ACD, right? For that one, I've got everything. I've got the base of 4, I've got a height of 5, so its area is going to be 1/2 times 4 times 5. 1/2 of 4 is 2, so I can then do 2 times 5 and get 10 square centimeters. All right. Now, before we move on, I'm going to see, no, can't get it. I want to be very, very clear that the triangle that I'm worried about, the triangle I really want to know the area of, is that one, okay? Triangle ABC. So letter B says, use your answers from A to calculate the area of obtuse triangle ABC. Okay, I'd like you to think about what you need to do with these two numbers to figure out the area of that shaded triangle. Pause the video now and figure out its area. Well, what I'm hoping you did was not what we did in the last problem. So in the last problem, right, we had these two right triangles that we calculated the areas of, and we added them up to find the overall area of the triangle. But in this case, that's not what's really going on. We know the area of that triangle, ABD, it's 35. We know the area of that triangle, ACD, it's 10. To figure out the area of this triangle, we actually have to take this one and subtract this one, right? I'm literally taking this and I'm throwing it away from this. This triangle is part of this one. This 10 square centimeters is part of that 35 square centimeters, and once I subtract it, that will then allow me to figure out that, which is easy enough. This area now is going to be just 35 minus 10, or 25 square centimeters. All right. Now, letter C asks, I want to keep that in there, does the general area formula for triangles still work? Verify. Well, for a moment, let me draw that triangle that we were just coming up with the area for individually, right? So that particular triangle looked something like this, right? It had a base of 10. It's a little bit harder to show the height of it, right? But the height, again, is the distance from this point down to the base, and that's going to be 5 centimeters. So does the generalized formula for a triangle work? Is the area 1/2 the base times the height? And the answer is yes, right? Definitely. And the answer is yes, because if I use that formula here, I'd have 1/2 times 10 times 5, and that would be 5 times 5, which would be 25 square centimeters. So it still works, all right? And that's the beautiful thing. It doesn't matter with a triangle, right? Whether it's a right triangle, an obtuse triangle, an acute triangle, a triangle that's been painted green, it just doesn't matter. As long as we know the length of one side and then the distance from the vertex that's not on that side down to it, well, then we can always take that length, multiply it by that length, divide by 2, and we have now the area of our triangle. And that's it. So let's wrap this thing up. Right? Area, as always, is just a measurement of the two-dimensional space that lies within a figure. Using the area of a rectangle, we were then able to find the area of a right triangle, and using that, we were then able to extend it to the areas of acute and obtuse triangles. And what we found was that in every one of the cases, all we had to do was take the base of the triangle, and there could be up to 3 different bases, right? Any one of the 3 sides could serve as a base. And we take that base length, multiply it by the height, right, the distance from the vertex down to the base, and divide by 2. And every time, that tells us how many squares fit inside of that triangle. All right? We're definitely going to be using the triangle area formula a lot as we move on to more complex shapes like trapezoids and parallelograms in the coming lessons. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.